Good morning class. Welcome to the online classes for physics of class 9th. We have started the chapter that is work and energy. You may have gone through the introduction part also that were given in the video. So previous video you have gone through the work, what was the type that we can do the work, and what was the angle through which we can do the work, and its types also we have seen. So this is what an introduction through your refresher part. See what was the work. That work can be defined as the product of force, that is the force applied on the body, then body get moved. So the product of force and the body, that it get displacement. So work is done when the force is produced on the body, and this force which is applied on the body is try to make that body to move. So when the work is said to be done only when the force is applied, and due to that force the body is tends to move. That means force produces motion on that body, then only the work is said to be done. And if you talk about the definitions, then when work is saying to be try to make a body move, then it will be equal to the product of the force and the displacement done by the body. So work is equals to force into displacement, that is F into S. And if you talk about unit, then it will be force is given as Newton and distance is given as meter. So together Newton meter is given as unit, but Newton meter is also said to be joule. So joule is equals to Newton meter. And if we talk about the CGS unit, then this joule will be converted into ergs. Okay. And work done against gravity, what that was, that whenever we are trying to move a body, like in this example, see, when we try to make a force on the body, and if that body get displaced or it starts moving, then the work is said to be done. And if the work is not done if the body doesn't move, like if he is pushing a wall, whether the wall will move by our force, any kind of force you apply or whatever the value of the force, the wall doesn't move. So if the body doesn't move, the displacement will be 0. And if you put the value of the S as 0 in the work done is equals to force into displacement, then F into 0 will be 0. So work done is said to be 0. And what we can say, that if a body get displaced or it moves, then only the work is said to be done. And if the body doesn't move, that means the work is not said to be done. So work is 0. Okay. Now work can be of anything, like if you are applying the force to push a body or to pull a body, then it is a kind of work done. Now if you are applying the force to lift that object, that means you are working against a gravity, right? Against gravity you are pulling that object. So one force is acting in the downward direction because gravity always act towards the center of the earth. So work is done here, but against the gravity, then the amount of the work done will be equal to that of the weight of the body, because now the force acting on that body will be in the downward direction, because in the gravitation chapter you may have seen that the weight is the kind of the force which is acting in the downward direction towards the center of the earth, and that force was given as mg, that is the mass along with the gravity. Together it was given as weight, and that weight is considered as the force which is acting in the downward direction along the gravity. So if you are just lifting any body against the gravity, then the force will be the gravity that is acting on our mass. So mass into gravity will be its force. F is equals to mg. And the displacement, now the body is not displacing in its position, there is no change in the position, but there is a change in the height, because you are lifting that object to a particular height, like 5 meter, 10 meter. So you are just lifting that object to a height, so height is given as h. So weight of the body into that of the distance will be considered as height. So force into displacement, now it will be changing into mgh. So this is one of the formula for the work done if it is done against the gravity. So the gravity will be working on its mass and weight also, and together the height displacement will also be there. So see the sample problem number 1, that is how much work is done by a force of 10 Newton. Means how much work is said to be done is asked if the force applied on the body is of 10 Newton and the body get moved by a distance of 1 meter in the direction of the force. Like what that means in the direction of force, like if you want to open the door, you try to pull it, so the door is also towards you, that means the force also in the direction, and together the displacing of that door is also in that same direction. So force and the displacement are in the same direction. Like if you want to push the door, then the door will be moving on that side, that is means that in the direction of the force. So if you are pushing it, so it is moving along the force. So when the direction of the force and the displacement is the same, so it is here that the moving of an object through a distance of 1 meter in the direction of the force. So here what is the displacement, that is 1 meter, and force applied is 10 newtons. So on multiplying this both, we can find out the work done. So work done is equals to force into displacement and 10 into 1 meter. So Newton meter will be given as joule. So the work done will be given as 10 joules. Calculate the work done in lifting a 200 kg of water. Now lifting condition came. So what I had told you, that whenever the body is lifted up, so you are working against the gravity. So the force will be now considered as our weight, that is mg, and now it get displaced to a vertical height of h, which is given as 6 meters. So mgh would be the formula for the work done. For mg, mass will be 200 kg, g will be 9.8 or 10 meter per second square, as it is already given in the question that to assume the g as 10 meter per second square, the value of g will be 10 meter per second square, h will be given as 6. So 200 into 10 into 6 will be given as 12,000 joules. So here are the examples, like in lifting the book from the floor, the man is doing work against gravity. So that will be considered as a formula for mgh. Similarly, in lifting the weights, here also mgh. So see the question number 3, that is a car weighing 1000 kg and traveling at 30 meter per second. Now it is already given speed and we don't know what the speeds formula for that of the work done. So we already know the equations of motion. So from there we can find out the other values which are required for work done. So 30 meters per second is stopped. Stopped means final velocity will be 0. Initial velocity is given as 30 meter per second of 50 meter per second, means it is displaced through 50 meters. So s will be given as 50 meter. Deaccelerating uniformly means now the velocity is decreasing, so acceleration is in the negative direction. So means value of the acceleration will be taken as negative. Now it is asking what is the force. So what is force is mass into acceleration. We know the formula for that. Mass is already given 1000 kg, but acceleration is not given, and we know the acceleration is now deaccelerated, so the value of a will be taken as negative. And we know by using the equation of motion we can find the value for the a. So v is equals to u plus at. If you find, then t is not used here, t is not given also, so we cannot use the first equation of motion. For second, it is given ut plus half at square. Here also t is used, but t is not given in the equation. So we will be using third equation of motion, that is v square is equals to u square plus 2as. Since the body is getting to be stopped, so v value will be 0. U will be taken as 30 meter per second. And if we talk about 2as, 2 into a is not given, we have to find. For s, it is already given that it displaced about 50 meter. So s value is 50, 52 is 100, and 300 square, 30 square means 900. 900 divided by 100, it will be 9. So acceleration is given as 9 meter per second square, but in negative direction since the body get deaccelerated. So the force exerted by the brakes, how can we find it out? Brake means acceleration is negative. So F is equals to mass into acceleration. Putting the value of m and a together, what we will find? That force is equals to minus 9000 Newton. But the second question was, what is the work done by the brakes? So work done will be force into displacement. What the force was? Minus 9000 Newton, but work done cannot be negative, na? So it will be 9000 Newton, and multiplying into distance. Distance means 50 meter. Together when we multiply, we got 45, and there are 4 zeros. Together we can write as 45 into 10 to the power 4. But we know that point should be there, so on taking the left side, the point will be added, that is 10 to the power 5 joules. Now work done by a force acting obliquely. Obliquely means we are taking an angle to the direction of the force, means there is some angle between your displacement and the force. In many cases, the movement of the body is taken to be an angle that you want to see. The example in this photograph, see a child is pulling a toy, but there is a tied thread to that of the toy car, and when he is trying to move that object, he will try to string that, right? String will be moved, so the body will also be moved. So pulling force will be along its string. So there is an angle between that pulling force along the string and the direction, that is how it is moving along the straight path. So there will be an angle theta. Theta is considered as an angle which is given as here you can see, since the force is having an angle theta, so it will be given as Fs was the formula for work done. But if you're talking about theta, some angle is taken for the horizontal direction which is named as cos theta. So cos theta will come. So Fs cos theta will be the formula for the work done in the direction of the force. So now here an example that a child pulls a toy car through a distance of 10 meter, means here S value is 10. And if you talk about that, the motion of the body, horizontal floor means 10 meters he is moving out in a horizontal flow. He had an angle, makes an angle of 60 degree with the horizontal surface, means the thread which he is moving with his hand with an angle of 60 degrees. So the value of theta will be 60 degree. So let me tell the values for the cos theta of different values. So cos 0 degree is always taken as 1 theta for 0 degree. If we take theta is equals to 90 degree, then cos 90 is taken as 0. If you talk about 180, then cos 180 is taken as minus 1. Okay, so these are the values for the theta of different values. So here the value is already given 60 degree. So what was the value for the cos 60? Then cos 60 degree is given as 1 by 2. So we already know that F as cos theta was the formula for the work done. F is already given as 5 Newton, S is given as 10 meter, and cos theta will be changed into cos 60 degree because already given the angle of 60 degree. The 5 into 10 and cos 60 is taken as 1 by 2. So 2 and 5 will be 25. So 25 joules work is to be done if it is pulled with a string with a force of 5 Newton towards the horizontal surface with an angle 60 degree. Okay. So this is about the force acting opposite to the direction. We already said that whenever the force is taken with an angle 180 degree, then it will be considered as that the force acting in the direction of the body will be taken as negative. Okay. So work is said to be negative if the value of the theta is taken as 180 degree. It is said to be positive if the theta is taken as 0 degree. It is taken to be negative 0 if it is 90 degree. So theta will be 90, then the work done is said to be 0. If theta is 60 degree or 45 degree or 90 degree, then the positive means 0 degree. Theta will be 0, 45 or 60, then the work done is said to be positive. If it is talking about 0, then the positive value of theta will be 90 degree. If you are talking about negative, then the theta's value will be 180. So if the force and the distance will be acting in the opposite direction, then also we can say that the work done will be taken as a negative work done. Okay. So these are the conditions which can be seen in the first part. Now in the next part we will be seeing that what was the energy. In the next class, that is on the Monday, we will be again seeing the chapters introduction part, and also we will be seeing the energy. So thank you class.